Hey everyone, so welcome to this video, and actually I'm going to start a series which is of data structures and algorithms. Okay, so we'll be discussing all the famous data structures which we have, like linked list, then stacks, queues, trays, graphs. After that we have advanced data structures like this segment trees. Okay, segment trees. So we'll be covering all these data structures in detail. So what we'll do is I'll make a playlist for each of these data structures, and in each of these playlists we'll try to solve one question. Okay, I mean one question per video. So in this video also I'll solve one question on tree. Okay, so let's see what exactly the question is. So this is a binary tree, and we just need to print the in-order traversal of this binary tree. So if you're not familiar with in-order traversal, then let me tell you. So the first thing that we need to do is we need to visit the left child. Okay, it has actually three steps. Okay, so the first step is to visit the left child of the node. After visiting the left child, print we need to print the root. Okay, we need to print the root. After printing the root, we have to visit the right child. So this is actually the steps that we follow in order traversal. So the first is to visit the left child, then print the root value, and after printing the root value we need to visit the right child of the node. So that is step number 1. This is step number 2, and this is step number 3. So we need to follow these 3 steps. Okay, so let's start with root. We'll pass root node as a parameter in the function in which that will calculate in order traversal for this binary tree. So we'll pass 10 as a parameter. So the first step will execute for this node. It means that it will visit its left child. So the first step executed, so it will visit its left child. Now the control is here. It means that we have to execute the first step for this node as well. So the first step is executed, means it will visit its left child. Okay, and for this also the first step is executed, and let's say its left child is basically null. Okay, it is null, so it will return back to its parent node. Okay, and the second step will execute because the first step is completed, so it will print that node. Second step is printing the node, so it will print 4. Okay, so 4 will get printed. Second step executed. Now third step. In the third step we are visiting the right child of the node, so it will go to the right child, and here the right child is null, so it will come back to its parent node. And for this node all the 3 steps are executed, then it will return back to its parent node. Okay, now for 6 we have only first step which is completed. Now the second step will get executed, so it will print 6 here because in the second step we are printing the root value. Sorry. Okay, and second step is completed for 6. Now the step number 3, that is visiting the right child, so it will visit its right child. And for node 8 we need to execute all these 3 steps. Okay, so the first step is to visiting the left child, which is null, so it will return back to its parent node. The second step is printing that node. Okay, so it will get printed here, and second step is executed successfully, and the third step is to visit its right child, so right child is also null. Okay, so it is null, and all the 3 steps are executed for this node, so it will return back to its parent node. So this is what we do in order traversal. Okay, So let's write C++ program for this. Okay, so let me open my editor. Okay, so what I'll do is I'll first include. Okay, so first I'll create a node. I'll create a node structure in which I will store one left pointer. Then this is the node data, and this is the right pointer. Okay, so this is the node value, and this is the left pointer. For this is actually storing the left pointer's address. Okay, and this is for storing right pointer's address. Now I'll create a function for creating the node. Okay, so node will pass data, or data as a parameter. Okay, and I'll create a variable which is pointer variable, and here we need to do typecasting. So I'll use malloc for allocation of spaces. Okay, you can use new keyword here. Okay, you can use new as well instead of using malloc. Okay, so temp of data is equal to x, temp of left is null because this is actually the fresh node. Okay, and temp of right is also null. After that we need to return the temp pointer. Okay, so this is just for creating a node in a node. Okay, so first what we'll do is we'll create all these nodes, and after that we will traverse this node and print the in order traversal of this binary tree. Now I'll write main function here, and I'll create this tree first. Okay, then root will call this function and pass 10 as a parameter. Then root of left 6, root of right is 18. Okay, its right child is 18. Then 6, 4 and 8. Okay, root of left and root of left of right, which is 8. Okay, now for 18, the left child is 15 and the right child is 21. So 15 and the right child is 21. So it is right and it is 21. Okay, so we have created this binary tree. Now we need to call an in order function, in order traversal. Okay, and we'll pass root as a parameter. Now return 0. So we have to create this function. Okay, so I'll write void, and the parameter is root. So here we need to write a condition. Okay, so if root is not is equal to null, then only we will execute all these steps. Okay, otherwise we'll return back to its parent node. So if root is not is equal to null, then we will execute these 3 steps. So the first step is to visit its left child. So this is the recursion, and we'll call the left child of root. Okay, After that we need to print the root node, so we'll write cout root of data, and after that we need to visit its right child, so root of right. Okay, so this is a recursive method for printing in order traversal of binary tree. Okay, so let me run this. Think okay. Okay, so here you can see that the output is 4, 6, 8, 10, 15, 18, 21. Okay, so first it will print 4, then 6, then 8. After that it is 10, 15, 18, 21. Then it means that it will first print all these things here, then it will print the root data, and after that it will print the child of root. Okay, so this is how you can write a recursive function for in order traversal. Okay, so that's it for this video. Thank you.